All right, so this is homework 9, problem 6. So the question states 66 kilogram diver is 4.1 meters above the water, falling at a speed of 4.9 meters per second. Calculate the kinetic energy as they hit the water. Okay, so the diver is on this platform and they are 4.1 meters above the water. They are falling, so they're falling at a speed of 4.9 meters per second. So I would say that's the initial velocity. Basically, they dive off of it and they have an initial velocity when they're diving. It says calculate the kinetic energy when they hit the water. So here, that's where we need to calculate it. So the kinetic energy, again, so kinetic energy is equal to 1/2 mv squared. So what we need to determine, one second. Yeah. So what we need to determine is how fast, so their velocity when they hit the water, right? Because that's going to give us our kinetic energy, because kinetic energy is equal to 1/2 mv squared. And this velocity is the velocity when they hit the water, right? So they have a kinetic energy when they first jump off, right? Because they have a velocity and they have a mass. But that kinetic energy is going to be different because as they're falling, they're going to be gaining more speed. They're going to get faster and faster because they're accelerating due to gravity. So we need to figure out what this velocity is here when they hit the water, right? So we're going to use kinematics. And so probably the best formula for this would be Vf squared equals V naught squared plus 2a and then change in y. The reason why we want to use this one is because we have an acceleration, which is gravity. We have a height because they're falling this distance. We have an initial velocity, and when you're looking for the final velocity. Okay, so our initial velocity was 4.9, so we square that, plus 2 times 9.8, which is the acceleration due to gravity, and then our change in our y, which is 4.1 meters. Okay, so we plug that in our calculator, 4.9 times 4.9 plus 2 times 9.8 times 4.1. And then we take the square root of that answer. And so the final velocity is 10.2162 meters per second. Okay, so that's the velocity that the diver has when they hit the water. So kinetic energy is equal to 1/2 mv squared. So this is the velocity that we're going to use. So 1/2, and the diver's weight or mass was 66 kilograms times 10.2162 squared. So calculated a kinetic energy as the diver is hitting the water at 3444.2 joules. So that's one way to calculate it. Another way to calculate it, which you should get the same answer, is the conservation of energy. So the conservation of energy states that the energy, okay, so energy of a system cannot be created nor destroyed, right? So the total energy at the end has to be equal to the energy at the beginning, right? So this equation just states that. It says the final energy has to be equal to the initial energy, right? Because if you rearrange this, you have E final, energy final, is equal to the initial energy, right? And energy can be broken down into kinetic energy, potential energy, this is like, gravitational potential energy, or like potential energy related to a spring. All of this stuff, any forces or any conservative forces or conservative, I forget what it's called, like basically any forces or any work or any energy that is conservative. Things that aren't conservative are things like friction. When friction is causing something to slow down, it's generating heat, and that energy is not transferred directly. I mean, it is transferred in the sense that heat can be calculated, but it's not something like this where you have kinetic energy, potential energy, those things. So basically, the energy at the end has to be equal to the energy at the beginning. So another way to think about this is the kinetic energy, and I'll just put a 1 here, and that's just denoting the scenario 1, like the first scenario, plus the potential energy, gravitational potential energy at 1 is equal to the kinetic energy at 2 plus the gravitational potential energy at 2. Basically what that's saying is that if I drop an object from a cliff, right, and it's not moving, then that means the kinetic energy is equal to 0, and the potential energy is just equal to mgh, which is gravitational. And so at this 1 scenario, it's only going to have gravitational potential energy. By the time the rock falls and hits the ground, now it's no longer going to have gravitational potential energy because it has no height. But it does have kinetic energy because that kinetic energy is 1/2 mv squared, and we're actually moving at a speed now. So basically all of this gravitational potential energy just transformed into kinetic, right? So if we did it similar to this, kinetic energy and the potential energy added up, which would be here, has to be equal to the potential energy and the kinetic in the second, in the final state, right? So going back to our diver problem, if we do the kinetic energy, we can just say kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final. So in our diver scenario, what is the kinetic energy initially? So initially, when they're up here, they have a kinetic energy of 1/2 mv squared. And this v is the v naught. And they have a speed, right? Because they jumped off at this speed, so they have kinetic energy. What is their potential energy? Potential energy is just mgh. So they have potential energy because they're at a certain height from the surface of the Earth. That's all going to equal to the final kinetic energy, which is 1/2 mv squared. And this v is the final velocity when they hit the water, plus the potential energy, which is mgh. Now they no longer have height because they're now at the surface of the water, so that height is now 0. So basically this whole factor would go to 0. Okay. So the problem's asking, what is the kinetic energy when they hit the water? Well, this is the kinetic energy when they hit the water, right? This is this final state. So we can plug in our numbers, and actually instead of plugging in numbers here, we're gonna just say that that is the kinetic energy final when they hit the water, right? we plug in the rest of our numbers, 1/2 66 times their initial velocity, which is 4.9 squared, plus the gravitational potential energy, and they're at a height of 4.1 meters. So plug those numbers in. So we have times. And that comes out to a kinetic energy final of 3444.2 joules. So the answers are the same, right? So we solved it this way. In the first way, we basically just figured out what their final velocity is going to be and used that to solve for the kinetic energy. But if we didn't want to figure out what the final velocity was, or we didn't know or something, then we could use this formula, basically. And this formula just states that the kinetic energy plus the potential energy at the beginning, so all the energy in the beginning, has to equal all of the energy at the end. But you get the same value.